This is question number 20 from the 3.2 and 3.4 MyLab math homework, and it's a doozy, y'all. Let's take a look at this one. There's actually two ways you can do it. You can do it just working with the function as it's given to you, or you can do some fancy algebra to simplify the function before we work with it. And I'm going to show you both ways. I'm going to start by working with the function as it is given. So anytime you're given a function, ask yourself what's happening to the input. So when I input an x into this function, where is it going? It's going into this exponent, but that exponent is part of an exponential function that's part of a base to the 8th power, okay? So let's look at this. So this is actually going to be a power rule function because I have a base raised to a constant exponent. It just so happens that the base is an exponential function. So we're definitely going to have to do some chain rule here. Okay, so just to clarify, if I had given you this function, if I had said f of x equals 3x minus 5 to the 8th power. Okay, see how your input is going to a linear base, and that linear base is to a constant exponent. You would know, oh, I'm going to use power rule, right? You would say, okay, drop the exponent down to the front. I rewrite the base exactly like I see it. I decrease the exponent by 1, and then I tack on the derivative of the base. And the derivative of the base is linear, so the derivative of the base just uses the power rule. So the same thing is happening here, except your base is ugly. Okay, instead of the base being this nice, pretty linear base, my base is exponential, but I'm still going to follow the power rule. So let's see the power rule at play here. Okay, so I'm going to drop the exponent in front of the base. So let's rewrite that. So I drop the 8 down. I rewrite the base exactly as it's given. So rewrite the base. Okay, so let's go ahead and do that. The base is exponential function here. Then I decrease that exponent by 1. And then I tack on the derivative of the base. The derivative of the base, okay. So this is derivative of the base. So let's go ahead and clean this up. Okay, what in the world does this give us? So we have 8. Then we have the base to the 7th power. And the derivative of this base is going to require chain rule in and of itself. So let's come over here and say, okay, if this is my function, e x to the 4, so e and the exponent is x to the 4th plus 5, that exponent up there is not a plain x. So when I go to do the derivative is e to the exponent, x to the 4th plus 5, but then we have to tack on the derivative of that exponent. So this problem has a chain rule within a chain rule. So when I take the derivative of that, I'm going to have e to this binomial exponent times the derivative of that exponent. Okay, so that would give me 4x cubed e to the binomial exponent. Okay, so that comes over here, 4x cubed e to the binomial exponent. Okay, it's a lot of stuff going on here. That's my raw derivative. This is the derivative I get when I do the power rule with the chain rule, and then the chain rule required its own chain rule because the base was so complicated. And now we're just going to clean this up with some algebra. So you're going to have to use some exponent rules from algebra here. So the easy thing to do is just recognize that we have an 8 being multiplied to a 4 being multiplied to an x cubed. So like those are nice and pretty. So I can multiply 8 times 4x cubed, and that's going to give me 32 x cubed. The yuckier thing here is that I see I have e to the binomial exponent in 2 locations. I have it 7 times in this base, and then I have it 1 time over here. So you have to use that algebra rule that says if you're multiplying the same base, you add the exponents. Remember that? So my base is e to the binomial exponent. And if I have it 7 times in this piece and I have it 1 time over here, I have it 8 times altogether. Okay, I know that's a lot. So let me show it to you, cleaning it up first with some algebra. Okay, and we're going to get this exact same answer. Just going to be a little bit easier. You know, algebra is supposed to make our lives easier, right? But we do not need to know the algebra. You can do the power rule with the chain rule. It just so happens that this one's extra yucky because when I did the chain rule, the base required its own chain rule. Okay, but we're going to end up with the same answer. So let's take a look at that. Okay, so now let's go back to that original function, and we're going to clean it up using some algebra rules, some exponent rules from algebra. And this is the rule I'm going to use. So the rule I'm going to use says that if you have a base raised to a power, and then that's raised to another power, you keep the base and you multiply the exponents. So for example, if I had x squared and that was raised to the 3rd power, I would really end up with x to the 6th power. We're using this rule and we're applying it to our original function, because in our original function, we have base e raised to a binomial exponent, and all of that's raised to the power 8. So let's take a look at cleaning that up using my rule. Okay, so I'm rewriting my function notation because only algebra is happening here. So I'm rewriting f of x. I keep my base and I multiply the exponents together. So I have this binomial x to the 4th plus 5 that was my original exponent. And I'm multiplying it to 8th because I raised it to the 8th power. I'm going to instead of writing the binomial first and the 8 second, order doesn't matter when we multiply. So I'm just going to move that 8 in front of my binomial and distribute it in there. Okay, so this is what my function looks like, keeping my f of x notation, because this is just algebra. Okay, my base is e, and then I'm going to have 8x to the 4th plus 40 as my exponent. And now I'm just going to start my calculus using the e to the x rule with chain rule. So now when I go to do my calculus, I'm doing f prime of x now because I'm applying my e to the x derivative rule with my chain rule. So the derivative of e to the exponent is e to the exponent. All right, that part stays the same, but then we have to tack on the derivative of the exponent. Sorry, there's a delay here with my app for a second. Okay, so now we just need to take the derivative of that exponent. So let's go ahead and do that. So I have e to the binomial exponent times, I'm just going to use the power rule for that exponent. That exponent is a quartic binomial, right? So I just use my power rule on that, and that's going to give me 32x cubed when I just use my power rule. Drop your exponent down, multiply it to the coefficient, decrease it by 1, all that good power rule right there. So it's looking closer. I see the 32x cubed that I got using my function as is. But this e to the x thing looks different, but all they did was factor an 8 out of that binomial exponent. Okay, so let's take a look at that. So I'm going to rewrite it with my 32x cubed first, since order doesn't matter when we multiply, and then I'll put the e to the binomial exponent second. And you could just enter this in my MATLAB and it will count it right. But to make it match what we originally got over here, all they did was they factored a GCF of 8 out of that binomial numerator. Okay, and then to make it look like what we got the first time around, then we just need to pull that 8 out as its separate power. So we're undoing that exponent rule, the power to a power rule from algebra. We're just undoing it. So we're going to pull that 8 exponent out, and that'll leave us with our e to the binomial exponent in there. And then it matches what we got using our first method. And again, you could have stopped way up here. MyMathLab would have counted this right. You didn't have to do all that fancy algebra. I just did it to show that our answers were equivalent. And I don't care which way you do it. If you want to work with a function as is, great. If you know some fancy algebra rules that you can use to clean up your function before you start the calculus, that's great too. And if you have any follow-up questions, just shoot me an email and we can talk it out.